Okay, good morning, afternoon, or evening, everybody. Welcome to the FCX, a science enabling system for visualizing and analyzing Earth science data, Earth data webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Daylight Saving Time, so we are going to go ahead and get started. And what I'd like to do first is just begin today's event with a few logistics. To ensure the best audio experience, all participants have been placed in silent mode. But if you have any issues or you have any questions, what I'd like for you to do is please enter those into the Q&A panel rather than the chat, and you should find that located on the right side of your screen. If you don't see the Q&A panel, click on the three dots at the bottom of your screen, and that should pull up your panel options, and then you can insert a check mark next to the Q&A panel. Okay, today's webinar is being recorded. The recording will be posted both to our NASA Earth Data YouTube channel as well as linked back on the event page within NASA Earth Data within a week of completion. Once completed, what I will do is I'll send an email to all the registrants and participants, and that email will include links both to the recording, the demonstrations from today, and the presentation slide deck that was used within today's webinar. As far as timing is concerned, today's webinar will be 1 hour and 15 minutes long, with 45 minutes allocated to the presentation and live demonstrations. And then we will have a 15-minute question and answer period that will follow directly after the presentation. Depending on the volume of questions that we receive, we may extend the Q&A session, but we do have a hard cutoff of 3:15 p.m. Eastern Daylight Saving Time. During today's webinar, we will have one speaker and one Q&A panelist. And let me, pull that up really quickly for you. And one Q&A panelist. Our speaker for today is Dr. Jeffrey Stano. Jeffrey is the Chief Scientist at NASA's Global Hydrometeorology Distributed Active Archive Center, or GHRC DAAC. He will begin today's webinar with an introduction to the GHRC DAAC and the Field Campaign Explorer. He will speak to the challenges that this tool addresses, and then follow up with a series of FCX, and that's the acronym for the Field Campaign Explorer, capabilities and Jupyter Notebook output demonstrations. Our Q&A panelist for this afternoon is Mr. Navaneeth Selvaraj. He is the lead front-end developer at NASA's GHRC DAAC, and he will be with us during the Q&A session to address any questions that you may have about the Field Campaign Explorer. With that, what I am going to do here is I am going to stop sharing my screen, and it is my pleasure to introduce today's speaker, Dr. Jeffrey Stano. Jeffrey, so let me stop sharing my screen and toss the presenter role over to you.
And Jennifer, thank you very much. Hello, everyone. Thank you for attending here today. We're very excited to have each of you here. I'll have my video off for the presentation. That way kind of prevent any lag or anything like that. And I'll pop back on once we come back to the Q&A session. So with that, I will stop the video on this end and start sharing the slides here. And Jennifer, just to make sure, are we seeing the full screen display here?
Yes, I am. Thank you very much. Appreciate that.
All right. Excellent. Thank you. Okay, well, once again, thank you, everyone, for attending. And as Jennifer introduced for us, we'll be talking about a cloud-based science enabling system for visualizing and analyzing data at a DAAC. So my name is Dr. Jeffrey Stano. We'll also have my colleague, Mr. Navaneeth Selvaraj, and also Will Ellett played a major role in helping bring this together. Obviously, with any major project like this, there's far more than just the three of us who are presenting here today. So I'd like to thank everyone on our team for everything that they've done to make the Field Campaign Explorer possible, as well as for helping bring together the information for today's presentation. So, as Jennifer mentioned, a quick outline here. I want to talk briefly about myself and my colleague, kind of talk about a little bit of what we do here at GHRC, and then give a little bit of an overview of what the GHRC DAAC is. What are the roles that we play? What type of data sets do we work with? Things like that. From there, I want to transition into what are the challenges that we're trying to address with the Field Campaign Explorer? What is it supposed to accomplish? What does it bring to the table for users? And then from there, we'll drop into kind of more of an overview of the FCX program. How does it operate? And the bulk of the presentation will focus on the FCX Playground. This is a new development that we have been working on this year to make FCX more accessible to end users. Then finally, we'll start wrapping up with some of the Jupyter notebooks that are being derived out of the FCX work. I'll talk about where we're going in the future for this, and then I'll have a couple of live demonstrations as we round out the presentation. So as you've already heard from Jennifer, my name's Dr. Jeffrey Stano, serving as the lead scientist for the GHRC DAAC. And essentially what my role is to help combine a lot of the atmospheric science expertise with the computer science expertise that my colleagues, such as Mr. Navneet Selvaraj, bring to the table. It's really kind of an exciting opportunity because many times Navneet and I will be sitting in one or the other's office and we'll spend a chunk of the afternoon just kind of bouncing ideas back and forth. We'll say, hey, wouldn't it be neat if we could do this? And then we kind of figure out, hey, what can we do? So it's a fun opportunity, and I enjoy doing that. A lot of my expertise has been in research to applications. So this really ties in well with what we're trying to do with FCX. And traditionally, I've worked with lightning applications. And so I have about 20 years of experience working with lightning data with the National Weather Service and NASA and other groups. On the right-hand side is my colleague, Mr. Navneet Selvaraj. As Jennifer mentioned, he is our lead front-end developer and is typically working with various individuals from our group on projects such as the Field Campaign Explorer. His emphasis is on open source activities and really trying to kind of develop the capabilities that we provide to our end users. He has 8 years of experience in software development. And also, I'd like to congratulate him going forward as he is approaching the end of working on his PhD program. So Navneet, congratulations on that. So let's take a quick overview of what we're doing with the NASA's Earth Science DAACs and GHRC in particular. Each of the DAACs are the Distributed Active Archive Centers, and we are associated with NASA's Earth Science Data and Information System, or ESDIS. The image on the right shows you where all of the 12 DAACs are located across the United States. And I've highlighted here in red the Global Hydrometeorology Resource Center, and we are located in northern Alabama in Huntsville. Overall, the role of each DAAC is to essentially process, archive, and really provide the documentation for all of the Earth science data that NASA provides. We're aiming to make sure that these data sets are freely available to anyone in the community. That's not just limited to US users. This is an international community. What we're also trying to do is we're trying to help the user community enable the use of these data sets. So in other words, we're working to be more than just a curator of these data sets. We really are trying to take the expertise that we have, both on the science side and the computer science side, to help the user community kind of integrate these data sets into their own research. Now, the GHRC DAAC, or the Global Hydrometeorology Resource Center, is one of 12 DAACs across the United States. Officially, we are a collaboration between the NASA Marshall Space Flight Center and the University of Alabama in Huntsville. Additionally, each DAAC kind of has its own specialties, and I will kind of show that here. GHRC in particular, we have over 600 data sets with around 150 terabytes of data already archived, and that is continually growing. And in fact, we're actually one of the smaller DAACs in terms of total data volume. A lot of our efforts are to focus on creating a comprehensive archive of each of these data sets, and we're trying to understand the dynamical and physical processes of various features. That could be storm hazards, precipitation, tropical cyclones, lightning, and that is coming from field campaigns as well. Our emphasis is in cloud-based tools. That's where a lot of our expertise is in. And so we're trying to work with that cloud-based experience, merge that with our science expertise, and to create an open science approach to enable users to work with the GHRC's holdings. As we see here on the right-hand side, that includes everything from precipitation, hurricanes, storm hazards, lightning, and field campaigns. So what are we trying to address? Overall, NASA has been moving to this concept of open science. And the idea here is that we want to be able to make sure that data are freely available to the user community. And this is also more than just simply making the data available. We're wanting to make sure that the procedures with which to manipulate the data, such as software or other visualization systems, are available to the community. We want to work to try to make sure that other communities within the research field that may not have had as much access in the past are getting that access. So open science is a very broad approach through here. So GHRC and all of the DAACs are working to advocate for open science. And in many ways, we have been doing that from the beginning because, again, our role is to make sure that this NASA Earth science data are available to the user community. We're going to do this through data stewardship and our expertise manipulating the data sets. Additionally, we're trying to continuously work with community outreach and participation. So again, this is going to various science team meetings, going to conferences, things like that. And then GHRC in particular, we're focusing on technology development to kind of support the accessibility of data sets, sharing the data and communicating that information back and forth. Now, a lot of that technology development, that does focus onto our expertise working with airborne and field campaign data, their information and knowledge sharing. And specifically, that's going to lead into the Field Campaign Explorer, which we're going to talk about more here today. So, as I mentioned, field campaigns and other missions make up the vast majority of the data sets that we have here at GHRC DAAC. This graphic here just kind of shows all of the various things that we have been working with since the early 1990s, all the way up into the present. And again, you can see that these kind of cover precipitation, storm hazards, lightning, those types of issues. We're also very excited that we were just approved for the Aloft field campaign. This is kind of a lightning and terrestrial gamma ray detection campaign that took place across Florida and the Western Caribbean back in 2023. So we're very excited to bring that together. And that's going to play a role with FCX as we go forward. So that brings us now to the Field Campaign Explorer, what we really want to talk about today. And what you see on the right-hand side, and hopefully this is playing properly here, is an animation of the FCX system. This is a kind of not a live, but a full demo of the display in FCX. And FCX is designed as a three-dimensional data exploration tool to visualize and analyze a wide array of diverse and coincident data sets. And what I mean by that is that you may work with individual kind of program managers or principal investigators, and they're an expert on their particular instrument or their particular data set. And so they can kind of visualize that on their local systems and things like that. But the issue starts coming down to how do we work with multiple data sets as which they come from field campaigns? Originally, FCX was built for just field campaigns, and you see that in the name. But it's not limited to that now. We're definitely moving beyond kind of the original role with FCX. The other nice thing with FCX is that this is an open source system. So in other words, you're not having to download anything. It's a cloud-based system. It's not, you don't have to load anything on your local system. And ultimately, particularly with the Playground, you are able to go in and actually get the code for FCX and start developing your own version of it. Currently, we've been working with, we have 25 different instruments that are now visualized in FCX, and we are continuing to kind of expand that as we go forward. And I see Jennifer has been pointing the links here that you see from NASA GitHub, where you can get access to FCX. Additionally, we've been publishing this to the Python package index, or PyPy. And you can see that link at the bottom here, and Jennifer has been putting that in the chat as well. Now, the goal is for FCX is to address a number of challenges that we have with three-dimensional data sets. One thing in particular is data complexity. We do know that as you work with field campaigns or work with various missions, you are working with multiple, massive, multi-dimensional Earth science data sets. This can be very, very difficult to work with. As I mentioned, individual not private investigators, but project managers or the individuals leading these instruments, they probably know how to work with that data inside out and backwards. They have software in their local system. They may have students working for them that have an idea of how to work with this. But when it comes to trying to integrate that so that you're showing not just one instrument, but multiple instruments at the same time, that gets to be very, very complex. And that's one of the issues that FCX is trying to address. And we saw some of that with that previous animation. There's also fragmented data systems. So in other words, we do not have a seamless integration across all these diverse NASA data sets to kind of bring everything together. And that holds true even with data sets within GHRC's own holdings. So we may have all the data for one field campaign, but until there was FCX to start bringing that together, you could not look at each data set in one system at the same time. And that issue gets more difficult, more complex when you start looking at data sets across multiple DAACs. There's also visualization gaps. There's essentially no standardized tool for these multi-source three-dimensional rendering systems. And so we're trying to build FCX to be that enterprise level tool to support that particular challenge. Additionally, just as well as we have with visualizations, there's analytical limitations. We don't really have the ability to interrogate all these data sets, particularly in this coincident or at the same time manner. So we're working to do that. Additionally, we want to look at the accessibility in open science. And we talked about that at the very beginning here. We need to work in a cloud-based environment that's open source so that you're not having to bring things onto your local system, and you can work with the software that's already been developed. So again, this software is not proprietary. You're able to see the software, work with it, and develop your own own APIs and plugins for it. And as we go forward, we're also looking at performance issues. Right now, FCX is kind of working with its own capabilities within the cloud. We would like to look at kind of GPU or graphical processing unit acceleration so we can work with really high resolution real-time visualizations. Now, that's going to be a future effort, but that's something that we're looking at as well. Now, as we go forward here, the two animations on this side by side here, the image on the right, the image on the left is just kind of showing a two-dimensional non-interactive animation. And this is showing lightning observations from various instruments, the geostationary lightning mapper, the International Space Station lightning imaging sensor. And you can kind of see where the flight path went through that white line over the area and those types of issues. On the right-hand side is what the same scene looks like as we're trying to pull things together through FCX. Again, now granted, remember that we have slightly different resolutions, things like that. So, but the main goal here is that FCX is providing a three-dimensional view that we can kind of pan around and zoom and look at things. So that kind of gives us an idea of the basics of FCX. Just simply, it's, again, this data exploration tool to work with coincident data sets in 3 dimensions. So we can visualize the data as well as analyze the data. The next step now is the FCX Playground. And what do we mean by that? Essentially, what the FCX Playground is that we're aiming to create this modularized extension of the Field Campaign Explorer. The idea behind this is that we want to make sure that we want to help users understand how to use FCX so they can create their own plugins for FCX. And so what this does, it kind of spins off each of the individual visualization components into standalone elements. So if you're curious about how the cloud radar system, which we have shown here, as well as the ER2 X-band Doppler radar, how would you want to work with that particular data set? Well, you can work with the playground and look at just the code focusing on that aspect. This really helps simplify the learning process. You don't have to worry about the rest of FCX and how that operates. You just need to look at that particular visualization component. For this whole process, we're working with the Amazon Web Server environment. And we have a couple of items that we're working with, which I'll describe in the next couple of slides. This includes data streaming through earthaccess, dataset transformation with Pangeo Forge, and a netCDF metadata viewer. And again, I'm just kind of reading off there, and we'll talk about that over the next couple of slides. So each of these components plays a particular role, and I provided links to each one of these things through here. First is earthaccess. This is a Python library. And essentially, this is helping users find, download, and work with data from NASA-related Earth science platforms. So that could be other DAACs, other locations where NASA Earth science data are located. So again, This is something that's trying to address one of the original concerns with the FCX, that it was only built around GHRC datasets at the beginning. So now with this FCX Playground and the tie into earthaccess, now we're beginning to work beyond just GHRC datasets. We can now work with datasets with other DAACs. And so that really helps with that collaborative approach going forward. Additionally, the second component is PanGeoForge. And really what PanGeoForge does is that this is taking large amounts of data, it helps organize it, and then store it in a cloud-ready format. And so this is an open source system for data extraction, transformation, and loading, or ETL. And the idea behind this is that we're trying to take data sets that are stored at GHRC or another DAAC, and if they're in netCDF format, bring that into a cloud optimized format, which could be ZAR or a cloud optimized GeoTIFF, and then kind of help that data set be in that cloud analysis ready format. And then the third component, obviously, is the Field Campaign Explorer, which we've been talking about already. Now, let's talk a little bit about the technical details here, and we'll talk about the structure of FCX. The first part is that FCX, the FCX Playground is going to operate within the Docker system. So what does that do for us? Essentially, what Docker is doing for us is that it allows us, the developer, to package all of the applications that we're working with here into a single application so that all the dependencies and other libraries and things like that are all taken care of. That way, you can work with this on your own local system or your own local cloud environment, and it will work the same no matter where you put it, because you are, again, using all the self-contained information through here. Having tried working with Python libraries myself on numerous occasions and the pain that is to get those libraries to work, I greatly appreciate the aspect of this Docker tool kind of containerizing everything to make it for a consistent and scalable deployment. From there, as you can see on this image, so we have Docker, which is kind of containing everything through here. And then we're working with the Fast API system. And really what this is kind of the coordinator of everything. It's coordinating the Earth observation data access through earthaccess. It's coordinating the data transformations from the native format into a cloud optimized format through PanGeoForge, as you see here on the kind of lower middle part here. And then lastly, focusing on the three-dimensional visualizations using the Field Campaign Explorer. So what really helps here is that this is a central hub connecting all of the components. And it lets us quickly build these websites or apps that can handle and share data. Additionally, we're working with this earthaccess Python library for downloading and accessing these data sets as well. Then as we go forward, we can then get into the S3 bucket. And essentially what this is the storage location inside of the Amazon Web Services where the data sets are going to reside once they've been processed and put together into this cloud optimized format. This is working through a WebSocket connection, and really this enables a real-time update between the Fast API backend and then the React front end. And essentially what that React front end is, that is the app that provides the real-time data access so that you can visualize the data through the Field Campaign Explorer. Additionally, Mr. Navani Selvaraj will be here as part of the question and answer session at the end. So if you have any further questions that you have here for this technical side, I'll be very happy to let you speak with him to ask those questions. So we've talked about FCX. FCX is this system that can bring together a three-dimensional visualization and analysis of coincident data sets. Okay, that's fantastic. Now we have the FCX Playground. So what benefit is that to the users? Well, right off the bat, we've explained how this helps us better understand FCX. We're trying to bring FCX out there to the community. That's why we have the Playground. It's open source. You can roll the software to your own systems. You can make your own instance of FCX. And so by doing this, you have the ability within the Playground to kind of understand how things work, tinker with things, try to change parameters and see what that does. We're also working to kind of integrate multiple NASA Earth science tools into one cohesive platform for the seamless data processing. And that's one of our goals here, is to take FCX from what it is right now to making it a more enterprise level tool across all of the NASA DAACs. Additionally, since we're working with this Dockerized system, it creates this self-contained system that we can deploy with end-to-end processing experience. So again, you don't have to worry about trying to get all of those individual Python libraries working on your own. You can work with what is already provided through here. And ultimately what that does, this then gives users a comprehensive user interface for three-dimensional visualizations and the geospatial analysis. And it kind of gives that added benefit. You can go to FCX proper and look at it through that way, but you can also go with the FCX Playground, and that's where you can work to try to develop your own components to FCX itself. Additionally, we really hope that this helps reduce the cost and development time by combining these multiple functionalities and helping users understand and work with systems instead of having to reinvent the wheel each time. I'll kind of go with an example for myself in my own research, particularly when I was a student, when I was working with lightning data and things like that. I had to kind of stop and understand, how do I open up these lightning mapping array files? How do I process these files? Well, I had to kind of figure out from the person who came before me, and then students that came after me had to kind of learn from me how to do it. And the idea with FCX is that we're kind of creating this location where you can see how these files are manipulated easily so that you can then build off of that instead of having to reinvent the wheel each time. And again, we're trying to work with the user community, so the groups that we collaborate with, such as the INCUS mission or the Aloft Field Campaign, and get their insight to help. They can provide us software which we can bring into FCX. Okay, what I'm going to show over the next couple of slides here is kind of a quick example of walking through kind of the FCX Playground and how to work with this. These three slides here will show just a still captures of the process, and then we'll have a short video at the end. We start with the earthaccess input form. So we go through here. We have the earthaccess. We've toggled that through here. We're pulling in a global precipitation mission iMerge dataset. iMerge is kind of this global derived dataset of precipitation across the globe. And the short name is just kind of an abbreviation. So instead of writing out the Global Precipitation Mission iMerge, and which is also an acronym, writing all that out, we can just say GPM 3 iMerge. We select a start and stop time for dates, a bounding box, and then we can kind of say where things are going, what we want to work with. We hit submit, which then takes us to the next page, which shows us the status. So once again, we are now showing through here in this top part, it's showing the data that we have, how many files we're downloading. There are 3 files, and allows us to track the process of that data access. And then lastly, we have the metadata viewer for these netCDF files. And this comes in, once again, we're working with that GPM iMerge data set, and we can see through here the various coordinates, the lat and long, the time, and the various variables that are associated within that particular netCDF file. So let's go over, and I will start this little video through here. And essentially, this is just going to show you walking through the process again. And you see this was put together by Navneet. So many thanks to Navneet here. You select earthaccess. He's showing how we can go up here, select our start and stop dates for the data set. Choosing November 30th, 2022. He doesn't want to make any changes to the bounding box, and he hits submit. Now you get a nice little pop-up telling us, okay, your form was successfully submitted. We now go into the status. And now you see Navneet, he has gone over, he's clicked the toggle on the right-hand side here. And now we're seeing a status showing that we're querying the data. What's our status through here? Are the data sets being downloaded? We're showing it's now in progress, it's downloading. And from there, he can click on the file path. Once again, click that little menu, see the individual files, and then it shows that we've actually downloaded that individual file if you want to download that file locally. And then from there, he will then go to the metadata tab. Once again, click that down arrow, and that will then open up the files to see everything that is inside of those particular netCDF files. And you can see him scrolling down, look at precipitation values, start times, and the other variables through here. And you see Navneet's kind of highlighting each of these individual variables. So that's essentially what is going on. That's kind of on the back end through there, trying to show kind of some of the technical approach to start the process. Now, as we start kind of wrapping up the presentation here, as getting ready to do some of the live demonstrations, uh, I want to mention these Jupyter Hub notebooks that we have in the cloud. And what they are allowing us to do, there's a lot of work going into FCX and the FCX Playground to create the visualizations for all of these various data sets. And so the goal here is this is a useful resource. Individuals may not be familiar with a particular data set. They may know how to work with the data set that they are the experts on, but maybe not the related data sets. And since FCX is already beginning to visualize that, why don't we use the capabilities of the FCX Playground where we can isolate the individual visualization code and create a Jupyter Notebook for that? And so what this does is this helps gives us a modular design. Makes it really easy for experimentation. So you can take, as the example I have here on the right, which is showing the ER2 navigation data, you can mess around with that and try to understand, okay, how do I open up a navigation file? What happens if I change certain parameters? How do I show that visualization? So it really is helpful in that respect to start creating this modular piece of software. It's also customizable. You can work with the code yourself. Once you have access to that Jupyter Notebook, you can do what you want with it. If you don't like using green for the navigation track, you can change it to blue. You can play around with understanding how those things work. Additionally, and this is what I really like, is using this for a data recipe. And we're working kind of expand our library to show these simple analysis and these workflows. And what I find very useful for these data recipes is that they show users how to open up a file and say, okay, how do I crack this open? How do I read through a file and then do a simple visualization? For myself, that's very, very beneficial. I learn from seeing examples. And by being able to see that example and go, that's how they got access to this variable. Now I can apply that to get looking at other variables and try to look at other displays within that data set. And as I'll show here, you can see too, you can also create the animations because it's using it comes from FCX. And so you can see through here that from that simple Jupyter Notebook, you get a nice little video that comes and plays out of this. This does allow for real-time collaboration. You can have multiple users working on that notebook at the same time, and they don't have to be in the same location. Additionally, this is a scalable resource. So all of this is operating within the cloud. So we're working with cloud-based infrastructure, so you don't have to, again, work within your local system. The other thing that's very nice about this is that it's accessible anywhere we have internet connectivity, and we've been doing this as a collaboration with NASA OpenScapes. All of the Python libraries and things like that have been established in the OpenScapes system. So we're working in this nice containerized environment so that, again, you can work with the notebook straight out of the box without having to do all the Python library installation. And again, having had to do that myself, I'm very happy to not have to do that. It's very useful to be able to do that. Now, as we're looking forward for the next fiscal year, we are looking for an interactive, integrated development environment. And essentially what that means is we're continuing to update our visualizations, bring in more data sets, and improve how we access the data and work with the data. We are NASA's Lightning DAAC, so we want to make sure that we continue to integrate our Lightning data sets and capabilities into the FCX Playground. One of those is the Geostationary Lightning Mapper and Lightning Mapping Array Tools system. This was developed by Dr. Eric Bruning at Texas Tech, again, showing the kind of the collaborations that we have with end users. And we want to kind of pull that into the Playground system to help with the visualizations and really work with the other Jupyter Notebooks that GHRC has already created. As I mentioned earlier on, we've been looking at this graphical processing unit acceleration and also using machine learning libraries to improve visualizations and data analyses. Another way that we want to improve the system is to include the GraphQL API. And this is going to help with querying metadata and more efficiently access that metadata. Already, we do work with some histogram code within FCX, but we want to continue to add more Python code to bring in more plotting libraries for this. And then lastly, we have again, the goal is to turn this into a more of an enterprise level system and not just a GHRC level system. And so we want to bring in more of the ESDIS tools to make FCX Playground much more robust and cohesive. Additionally, what I'm very excited about right now is that we have been accepted as the DAAC to archive the aloft data from the field campaign, as well as from the Investigation of Convective Updrafts, or INCUS mission. We are working with those science teams right now. INCUS is set to launch in a couple of years, but we're already working with the science team. And so the goal here is to say, okay, we have created this system, but now we want to work with you, the science users, the science developers, and how can we better enhance FCX to help you with your displays? INCUS is going to be very interesting because there may be an opportunity to work with FCX in near real time with the INCUS mission. And so this is going to be an opportunity for us to grow and enact further growth for FCX with these collaborations. Here are a couple of the links. And again, this is all going to be available from Jennifer in the chat and everything, and also after the presentation. With that, I'm going to pause it here, and I'm going to switch over for the next couple of minutes to show a couple of examples through here. So I'll close this out. I'm going to change pages here. And Jennifer, I want to check to make sure, can everyone see? You should be looking at what looks like a Jupyter Notebook. There should be some code on the page, things like that.
Yes, that is what I can see. If everybody can see that okay, if you could type a quick note in the chat, that would be useful. Thanks, everyone.
Great. Thank you, everyone. I appreciate that. So what we're doing right now is this is just showing a couple quick examples of these Jupyter Notebooks. And I said one of the examples would be looking at the navigation data from the ER2. So we're going to recreate that image through here. What's nice is that you see how the code is broken up into individual components. And again, I'm kind of going into detail here for individuals who may not be familiar with the not the FCX Playground, but these Jupyter Notebooks. And it shows you each of the individual steps as you go forward through here. Now, one thing I want to do, this is kind of a quick live demo here right now. We're going to come down to line 9. And we have this long kind of URL through here. I'm going to go up to where we have our data stored. I'm going to come up to the upper left here, and I want to copy the download link. I'm going to grab that. I'm going to come back down to line 9 through here. I'm going to highlight this link. And we want to make sure that we have the most up-to-date data through here. I'll put that in. And we can see it's red or orange, depending on what color you're looking at, and indicating that this is our data set at this point. So I'm going to go up here. I'm going to restart everything. There we go, restart. And as you go up, you can see it's processing in real time right now. And it shows that star up here. It's indicating it's working on that step. As soon as that star is done, it goes back to the number. So that's 1 through there. We start scrolling down. And as you now see, we just saw that pop up. Here is and again, it has the functionality of FCX as well. I can pan and zoom. I can look around. We can see the ER2 is just kind of sitting by the hangar at the moment. I'm going to kind of speed things up a little. We'll move down a little bit here. And it starts playing again. Basically just waiting. The ER2 is just kind of sitting there, and apologize. There we go. Taxis out to the runway, and it takes off, and it's flying around, and we can zoom out. We can see all of the tracks that it takes. It was doing its various plots through here. So that's one aspect that we can work with. So we can work with other data sets, create the animations. Another one that I want to show real quick in the last couple of minutes is this International Space Station Lightning Imagers recipe. And as we're beginning to, I want to focus on this one because, as I mentioned, we're doing more than just field campaigns. And the INCUS mission in particular, that's going to be a small sat mission that GHRC is working for. We've worked with the International Space Station Lightning Imaging Sensor, the ISS LIS, for many years. And we want to be able to show the data sets and show where that orbit track is. So this is kind of one through here that we've developed from FCX again. I'll restart everything, and we'll start going through here. And you can see the processing going through here. Then it's going to pause real quick because this it wants some user input. It's like, okay, I'm going to look at data from 2022, November 19th, and I want to look at the daily plot. So it's going to take that user input. It's going to go through, start processing the data. You can see it's showing us a status update of everything. Excuse me. And as it's finishing up this processing through here, you'll then see a final plot come up in the next moment. And again, very, very basic display at this point. but this shows the ISS-LIS orbit path for the entire track, all the tracks over November 18th from 2022. This is showing a couple of days as well. So again, just a real quick, simple display of what we can do with this and showing that FCX can support more than just the field campaign data sets. Now, I'm going to switch over in the last couple of minutes here, probably about 5 minutes here, and talk about some of the FCX data sets that we can work with. If we go to the live page through here, we can see we have a couple of the field campaigns that we're working with. One data set in particular that I will look at is from the convective processes experiment aerosols and winds, or the CPEX AW data set or campaign. And you see it's loading up through here, doing a quick little load, lets us know what our processing unit is. And this is just kind of a fun one through here. We have it loaded up automatically looking at the ER2. And there we go. Oop, move down to here. And what I want to do here, I'm going to back things up in time a little bit. Let's go back a little bit through here. And we'll have the ER2 go back a little bit. We'll kind of fly on by. And then what we'll do at this point is we're going to stop it here. And we're going to move it forward, move pretty fast in time here. Have the ER2 fly by once again. And then you'll see this red line. This is actually a drop sonde, or an instrument package that was dropped out of the aircraft. And it can measure temperature, wind speeds, dew point, and other variables. And you just kind of see that dropped out of the aircraft through here. And you see the trajectory that it took going back down to the surface. And if we zoom out, we're kind of in the Bahamas right now, looking kind of northeast to southwest here. Additionally, I can click on this, and we get a quick little skew-T log-P diagram showing temperature, dew point, and winds that were observed from that drop sonde from that particular instrument here. I kind of like this one. Again, coming from a meteorological background, I work with drop sondes and radiosondes, and so it's kind of fun being able to see that three-dimensional track through there. Now I'm going to refresh everything. I'm going to come back up here. I'm going to go to the GOES-R post-launch test field campaign. I like this one because we have a lot more of the data sets all kind of pulled together through here. And this has a number of things that we can look at. You've seen this image. We showed an image of this during the presentation. But I'm going to start over on the left-hand side. You can see all the data sets that are loaded. One of these is the Advanced Baseline Imager that's showing all the cloud cover through here. I'm going to turn that off real quick. So we can turn that off. I can toggle that back on if I like. I'm going to turn off the geostationary lightning mapper and a couple of these other data sets through here. And what I want to really kind of focus on, we have the cloud radar system, which is this curtain of data through here. We also have the cloud lidar physics. I'll turn that one off, this one off. And the lightning instrument package, that's showing the electric field. So it's showing arrows or vectors. And you can see real quick that we can pan and zoom. We can look at, you see these little dots. This is from the Oklahoma Lightning Mapping Array. And you're seeing the three-dimensional display of the lightning data, the individual lightning channels. I can then come down and really kind of show you that three-dimensionality as we come through here. But also it's a dynamic display. If I zoom in, you'll see that that will start filling in with additional data through here. So again, it's kind of reactive to your zooming in and zooming out. Additionally, as I've mentioned, this is a data exploration tool. So we're working with the GOES-R post-launch test field campaign. If you want to know more about that, I can click on links. I can go to the landing page, and that will take me to all the information about this particular field campaign. Additionally, I can get a description of the campaign off of our webpage. And additionally, if you are interested in a particular data set, I can click on the data link through here on the left-hand side. And if you're interested in the cloud radar system, I can click on that. And that takes you to the landing page for the cloud radar system. That gives you all the information about the cloud radar system. You can download it and also go to documentation and go ahead and get the user guide for that particular data set. Again, I'll pull that up through here. Now, I'll go back to FCX at this point. In basically the last minute or so here, there is a nice timeline view. And I particularly like this because this shows all of the data sets that are being displayed at the moment. And I can then move the timeline tool over it to see what data sets are available coincidentally at the same time. So in particular, I'm going to go back to the display. and I'm going to turn on the ISS LIS, the International Space Station Lightning Imaging Sensor. And you can see then that the overpass for the ISS LIS was roughly around that 0548 UTC. The last tool that I want to show, we can do the histograms. I don't have a whole lot of time to do that, so I'm going to go back to the data viewer. But with a subsetting tool, I can click on this, click on Start, and begin playing the data. And this will start going through here. It will pick a start time, and then I'm going to stop again through here. So basically, I'm selecting I'm looking at about 10 minutes worth of data. I'm going to hit Submit. And it's going to start kind of pulling together that request for us here. I get on the left-hand side this little green pop-up saying, oh, we had a successful invocation. It's going to start gathering up the data at this point here. I can click on the Subsets tab. I can click on the down arrow through here, and we can see now all the various data sets that were part of that particular display that are being downloaded within that particular time frame. So I'm very excited by this, as you can kind of really subset in time and space the data that you want to work for. And so with that, I'd like to thank everyone for your time here today. And Navneet and I are going to be very excited to answer your questions. And with that, Jennifer, I will stop sharing here and hand it back to you.
Okay, thanks so much, Jeffrey. So at this point, what I will do, I'm going to open the final optional polls, and then I'm going to hop straight into the questions. We do have a few in the that were posed within the chat. So give me just 1 second here. Great. So let's get to our first question here. And just a reminder, if you have any questions, it would be super helpful if you could type those into the Q&A panel, which should be located on the right side of your screen. To activate that, if you don't see it, click on the 3 dots at the bottom of your screen, which will pull up your panel options, and then you can select insert a check mark next to the Q&A panel. All right, so the first question here, I apologize, it requires some scrolling in the chat. That's why the Q&A panel is a little bit more ideal. So the first question is, are you going to include European LI star data to GHRC DAAC?
Oh, that's a very good question. I think what's going to happen first is we're going to be focusing on the various data sets that are incorporated into the various DAACs. So the various NASA data sets, things like that. That being said, we do have, with the FCX Playground and things like that, that gives you the opportunity to kind of bring in your own tools into the system. And again, if you have questions about that, we want to work on developing some training on how to do that as well. So hopefully that's going to be coming out sometime in the next year or so here. So it doesn't necessarily, so directly, no, we won't be doing it personally per se, but that's definitely something, if there's an interest, please reach out to us and we can look to see what we can do to kind of help support those efforts.
Well, thanks so much, Jeffrey. Okay, so the next, I just didn't know if maybe you want to add to this. It's really a comment / question, and the comment is, wow, I really need to get up to date. You can render 3D with JavaScript through IPython. If anybody, Navneet or Jeffrey, if you have anything to add to that.
I'm going to hand that one to Navneet real quick here.
Oh, yes, Jennifer. We could really do wonderful things with the Jupyter notebooks. Now that we have access to iframes and web portals that can be included in the Jupyter Hub notebooks, we could do wonders.
Well, thank you very much, Navneet. And let me just make sure I haven't missed any questions in the chat. And then I'm going to hop down to the Q&A. Bear with me. Thanks, everybody. Appreciate that so much. All right. All right, perfect. We're going to jump down to the Q&A. Okay, so how long have you been working on this playground?
Navneet, I would say the playground has only been probably in the past year, maybe a little over a year at this point. FCX proper has been worked on a little bit longer, but I believe the playground has been about a year. Is that correct, Navneet?
That is correct, Jeffrey. Yes.
Okay.
So I would say, yeah, around 4 to 6 months full time.
And a lot of this work that's been going on, again, my hat's off to Navneet. I mean, it's really kind of incredible. Again, coming from a meteorological background and then watching what you can do on the computer science side is just fascinating. And so, like I said, it makes the conversations that Navneet have on a regular basis always a fun opportunity. But a lot of this has been through Navneet's work and also his coordination with various students that have come through the GHRC program as well. And so it's been a handful of people doing this as time permits and as students come through. So I'm very excited by the work that's going on, and we're definitely trying to make this much more of a, kind of, if you will, a front burner project or a priority project for us.
Well, thank you, Jeffrey. I am just looking to see if there are, I don't see any additional questions in the Q&A, and I don't think I've missed any in the chat, but let's see here. Oh, okay. So we've got a couple now. So this is great. So the first is, apologies, I may have missed the details about the subsetting process. Is this meant to be applied to all the data sets that can be entered into FCX? The different structures of the data feel overwhelming.
Yes, and I do apologize. I did that subset fairly quickly at the end here as I was kind of running low on time. So I do apologize. That went a little quickly. But yes, if the data are in FCX, then the subsetting tool would take that. Part of what happens behind the scenes, and again, Navneet can correct me if I don't get the details completely accurate, is that we're taking the data sets and bringing these into a cloud native format, so ZAR or cloud optimized GeoTIFF. And so that helps bring all these different things such as iCart for aircraft tracks, netCDFs for other data sets, and brings them all into this cloud optimized format, which makes it a little bit easier to operate for subsetting and things. And then Navneet, if you have any additional components that I'll hand that off to you.
Oh, no, Jeffrey, you covered it all. Thank you.
Thank you.
All right, well, perfect. And what I was going to say, so one of the questions was regarding, just to point everybody to this, was regarding whether or not the source code is available somewhere, and Navneet has placed the link to the source code for the Field Campaign Explorer within GitHub in the Q&A panel, so you can find it there. Let's see, and what I wanted to say while we're waiting for additional questions is that we are recording this afternoon's event, and what I will do within the next couple of days is send a link to both the recording as well as to the individual, to the presentation slide deck and to the individual demos that were recorded and embedded in the presentation. So I uploaded the PDF separately, and all of the demos, so I'll include those links so you have access to all of the content that has been presented here today. So let's see, are all of the links provided in the chat already in the slides? Yes, I believe so. Generally, what I will do is one of my host responsibilities is try to pull all of the links from any presenter's slide deck in advance so that when folks are taking a look, you know, they'll have that reference. All right, so let me do another check here.
And Jennifer, as you're checking,
Sure.
as individuals, if you start working with the FCX, whether it's in the FCX Playground or FCX proper with the open source code, if you have questions, comments, critiques, or recommendations, we are all ears. That helps us make sure that we're doing what the community is interested in. So obviously, for myself and the other atmospheric science people here at GHRC, we can focus on our backgrounds, our expertise, and the data sets that we're working with. But obviously, we can't know everything. And so being able to have other users come in and say, hey, you know what, this would be interesting or this would be useful, that's great feedback for us. And we'll be happy to work with that.
Okay, thank you so much, Jeffrey. And I assume by this question in the chat, will there be a replay provided? Yes, I have recorded this afternoon's event, and I will send a link to both all registrants as well as participants. So if you have colleagues who registered and were unable to attend today, they will receive a link to the recording so they you can watch it again or watch it for the first time at your leisure. All right, let's take another look here just to see whether or not there are any additional questions. If there are not, let's see, scanning. If there are not, what we'll do is we will log off from the audio component and we'll leave the virtual meeting space open an additional, let's see, I think we've probably got a good bit of time left on the polling questions here. So let me just take a look actually. So we will leave the virtual space open an additional 20 minutes or so today, just so everyone has an opportunity, if you're interested, to fill out the optional polls. We really do appreciate your input. The input that's provided, although optional, really helps to define user needs and also helps to drive the focus of upcoming webinars or future webinars. And so we really do appreciate this qualitative feedback. It's super important. All right, let's see here. There might be something else in the chat. I don't see anything else in the chat. And let's double check the Q&A. No, I don't see anything else. So with that, what I'd like to do is thank this afternoon's speaker, Dr. Jeffrey Stano, and also to thank our Q&A. Oh, we do have a question. Our Q&A panelist, Mr. Navaneeth Selvaraj. I know it's quite late where he is joining in from. Okay, so the next question is, how many people have been working on the Field Campaign Explorer?
Navaneeth, I'll let you, because you've continuously, it's been a small number, but we've had a number of individuals work on that. And then Navaneeth, I'll let you answer the rest of that there.
Oh, yes, Jeffrey. So it's around, I would say around 1 or 2 full-time employee, and we'll be having students cycle through their semester. Students will be working part-time on these projects, and they would have a good experience learning about the instruments and software development. So I would say like a couple of students and 1 or 2 full-time developers.
Well, thank you so much for that response. I really appreciate it. I'm just looking to see if there's anything else, and I don't think so. So with that, I'd like to thank everybody for joining us this afternoon. We appreciate your time and appreciate your participation. And with that, we will log off from the audio component, and I'll leave the virtual meeting space open in case you think of something.
Well, thank you. And Navaneeth, thank you very much, especially for the time difference for everything. So thank you. And Jennifer, thank you to you and your team for helping organize this. And it's been fun as always.
All right, perfect. All right, well, thanks so much, everybody. We hope to see you at an upcoming event. All right, take care now. All right, goodbye.